Assalamualaikum. Continuing our lecture online, Chapter 1 AC Circuits, Introduction to AC Circuits. So today we will continue our next topic, which is phasor representation of sinusoid. Phasor. Phasor is a complex number that represents the magnitude and phase of sinusoid voltage or current. So this is sinusoid equation. V equal to Vm cos omega t plus phi. Cos. Okay. So it is normal to find the equation in sine, but there is a little bit different between cos and sine in terms of phi. Okay, so we concentrate this cosine equation. V equal to Vm cos omega t plus phi. Phi is phase angle. So this equation in cosine wave can be simplified into complex number in the form of polar, exponential, and also rectangular. Okay, we will go one by one. However, in this class we will concentrate only two, which is polar and rectangular. Okay, so converting this equation, cosine equation, into polar, we only take the magnitude Vm and the phi, the phase angle. Okay, so how we convert this equation into polar? We just take this Vm become the magnitude and the phase angle become the phase. So Vm phase phi. Exponential, we can convert into exponential form into this format: Vm e j to the power of j phi. Okay, and another form is rectangular form. From this same equation, convert into rectangular form: Vm cos phi plus imaginary j or I Vm sin phi. So this is rectangular form, real and imaginary. Real Vm cos phi plus imaginary part j Vm sin phi. Okay, this is the normal format of polar and rectangular in complex number. Okay, example. Phasors. Example, V equal to 12 cos 377t minus 60 degree. So converting this equation into polar, we take the magnitude 12 and the phi, the phase angle, minus 60. So polar, we have 12 with the angle of minus 60. Converting this into rectangular, we can use the calculator and we will get this 6 minus j 10.39 or j 10.4. We can do this using calculator. Conversion from polar to rectangular. Next, this is basically the theoretical part of polar, theoretical explanation of polar and rectangular. Okay, so in polar we have imaginary axis and real axis. Similar in complex number, we have imaginary axis, J or I, and real axis. Or here we have X and Y. X is the real part, Y is the imaginary part. Z is the magnitude, phi is the phase angle. So in polar, we represent the number in terms of magnitude and phase, where the rectangular we represent in terms of X and Y. However, it is representing the same point. In this example, represent this point. Okay, so what is the X value? X value is the X is the Z cos phi. Z is this magnitude, cosine this angle. Y is Z sine theta. Z is this magnitude and sine this angle. So we can get this. We can get the value of rectangular form. And for the polar, Z is the surd of root 2 of x square and plus y square, and phi is the invert tangent of y over x. This is common. Now we don't really see this. We just use our calculator to convert from polar and rectangular. Complex number addition and subtraction. Normally, we will say that addition most easily performed in rectangular coordinates, and also subtraction. So subtraction and addition is easily performed using rectangular format. This is the example. And multiplication and division mostly easily performed in polar coordinate. So if we have the multiplication and division, we will perform using polar coordinates. Okay, so this is the example. If multiplication A and B, so we multiply the magnitude and the angle we add the angle, the phase angle we add, and we multiply the magnitude. For the division, we divide the magnitude and minus the angle. However, using a certain calculator, we can strictly do any operation, either multiplication, division, addition, or subtraction, straight away without need of conversion from rectangular to polar or polar to rectangular. Okay, so this is the example of how if we have the equation represented in terms of sine instead of cos, so there is a slight we need to be careful of the phase angle. If the sinusoid voltage represented by the sine function, then subtract the phase phi to 90 degree. We subtract the phase to 90 degree. So this is something to do with lagging and leading also. As example, we have the equation sine wave Vm sine omega t plus 10. So we have the sine equation here, sine instead of cos, we have sine. So we convert this first into cosine, into cos. So we minus 90 degree. So omega, so become Vm cos omega t plus 10 minus 90 degree. This is basically the same equation. We convert from sine into cos. So the angle has been changed, minus 90. So instead of 10, we have minus 80. So from this cosine, we can straight away apply straight away, take the value to write into the polar form. So now we have Vm angle minus 80. Okay, example 2. Example 3, given y1 20 cos 100t minus 30 and y2 40 cos 100t plus 60. So express y1 plus y2 as a single cosine function. So we will discuss this in the next video. So that's all. You can try this first, and then we will discuss after this about this the solution for this question, simple question. So that's all. Thank you very much.